Charles Darwin spent decades studying evolution, natural selection, and the origin of species. He rewrote how humanity understands life on Earth. And then for his very last book, he chose to write about worms. Not exotic worms, not some rare species from a remote island. Garden worms, the ones living in your backyard right now. The book became a bestseller, outselling On the Origin of Species in its first year. In it, Darwin made a claim that scientists at the time thought was absurd. He said that earthworms were the most important animals in the history of the world, and that without them, agriculture as we know it would be completely impossible. 145 years later, modern soil science has proven he was right, and the method he described for attracting them to dead soil is something almost no gardeners are using today. But this story doesn't start with Darwin's book. It starts with a question that nobody in the 1700s was asking. What if the creatures farmers were killing on site were actually the ones keeping their soil alive? For most of agricultural history, earthworms were considered pests. Farmers across Europe saw them wriggling through their fields and assumed they were eating roots, damaging seeds, and disrupting the soil structure they'd worked so hard to create. They poured salt water into worm tunnels. They stamped them out when they surfaced after rain. The idea that a slimy, blind, boneless worm could be doing anything useful underground was considered laughable. Then in 1789, an English naturalist named Gilbert White published The Natural History of Selborne. In it, he made a quiet but radical claim. He suggested that worms might actually be beneficial, that their burrowing loosened the soil, that their castings fertilized it, and that gardeners should think twice before destroying them. Almost nobody took him seriously. Darwin did. He read White's book as a young man, and it planted an idea that would occupy his mind for the next 4 decades. Between his work on evolution and natural selection, Darwin ran a series of private experiments on earthworms that most people have never heard about. He kept worm colonies in his study. He played music for them to test whether they could hear. He offered them different types of leaves to see which they preferred. He measured how much soil they moved, how deep they burrowed, and how they reacted to light and vibration. For 40 years on and off, Darwin was studying worms the way only Darwin could study anything, with obsessive, methodical, patient curiosity. The book that came out of all that work, The Formation of Vegetable Mold Through the Action of Worms, was published in 1881, the year before he died. It was the last thing he ever wrote, and it contained a conclusion so bold that the scientific establishment didn't fully accept it for another century. Darwin argued that earthworms are responsible for creating and maintaining the topsoil that all terrestrial life depends on. He estimated that worms in a single English pasture could move roughly 20 tons of soil per acre per year, enough to create a new layer of earth 7 inches thick in just 3 decades. He wrote that it may be doubted whether there are many other animals which have played so important a part in the history of the world as these lowly organized creatures. That wasn't poetic exaggeration. It was a scientific claim backed by decades of data. And it turns out he was lowballing it. Modern research has gone far beyond what Darwin could measure with his Victorian instruments. We now know that earthworms don't just move soil around, they fundamentally transform it. When a worm eats its way through the ground, it's consuming a mixture of organic debris and mineral soil. Inside the worm's gut, that material gets ground into extremely fine particles and mixed with enzymes and beneficial microorganisms that live naturally in the worm's digestive tract. What comes out the other end is called a casting, and it's one of the most nutrient-dense natural substances on the planet. Worm castings contain 5 times more nitrogen than the soil the worm ate, 7 times more phosphorus, and 11 times more potassium. Furthermore, the nutrients aren't locked up in complex organic compounds the way they are in raw compost. They've been pre-digested, broken down into forms that plant roots can absorb immediately. A single gram of quality worm castings, less than a quarter teaspoon, contains billions of beneficial microorganisms, not millions. Billions of bacteria, fungi, protozoa, and nematodes that continue cycling nutrients long after the worm has moved on. And unlike synthetic fertilizer, which releases everything in a sudden chemical flood that can burn roots and leach into groundwater, worm castings release their nutrients slowly over months. Plants get a steady, sustained supply of exactly what they need, delivered through a biological system that's been evolving for 600 million years. This is where the story takes a turn nobody expected. A comprehensive meta-analysis published in a peer-reviewed ecology journal compiled every study ever done on earthworm impact on plant growth. The conclusion was that earthworm presence in soil leads to a 25% increase in harvested crop yield and a 23% increase in above-ground plant biomass. That is 25% more food from the same soil with the same water and the same seeds. The only variable was whether worms were living in the ground. To understand why the impact is that large, you need to see what's happening underground in 3 dimensions. Earthworms don't just create castings, they build infrastructure. There are 3 ecological groups of earthworms, and each one works a different layer of the soil. Epigeic worms live on the surface and in the top inch or two, feeding on fallen leaves, dead plant material, and kitchen scraps. They break this organic litter down into smaller particles that other organisms can process further. Endogeic worms work the middle layer, creating horizontal tunnels through the topsoil and mixing organic matter into mineral soil as they go. And anisic worms, the big night crawlers, build deep vertical shafts that can extend several feet straight down, connecting the surface to the subsoil. Night crawlers surface at night to grab fallen leaves and organic debris, dragging it down into their burrows, where it decomposes and enriches the deep soil layers. They also build structures called middens over the mouths of their burrows, small mounds of mixed plant residue and castings that serve as both food storage and protection. If you see tiny piles of granulated soil mixed with leaf fragments on the surface of undisturbed ground, you're looking at nightcrawler middens. Each one marks the entrance to a vertical highway running deep into the earth. Those tunnels matter a lot. Earthworm burrows can increase soil aeration by up to 75%. They create channels that allow rainwater to soak into the ground instead of running off the surface, which reduces erosion and means more moisture reaches plant roots during dry spells. The burrow walls are coated with mucus and lined with castings, creating nutrient-rich microhabitats where root tips preferentially grow. If you've ever noticed that plant roots seem to follow old worm tunnels, that's not a coincidence. The roots are chasing the nutrients the worms left behind, and worms don't work alone. Wherever worm populations thrive, the entire soil food web comes alive around them. Beneficial bacteria multiply in their castings. Mycorrhizal fungi network through their tunnels. Protozoa graze on the bacterial colonies, releasing nitrogen that plants can absorb. The worms are the engineers, but what they're really building is a complete underground ecosystem. Remove the worms and the whole system collapses. Attract the worms and everything else follows. So why do so many gardens have almost no worms at all? Because most modern gardening practices are specifically designed, accidentally, to drive worms away or kill them outright. Tilling is the first and worst offender. Every time you run a rototiller through your garden bed, you're doing 3 things that devastate worm populations. You're physically cutting worms in half. Despite the old myth, a cut worm does not become 2 worms. It usually just becomes a dead worm. You're collapsing their tunnel networks, destroying months or years of underground infrastructure in a few minutes. And you're exposing moist subsurface soil to sun and air, drying it out rapidly and creating conditions that surviving worms will flee from. Chemical fertilizers are the second problem. Synthetic nitrogen salts acidify the soil over time, making it inhospitable for worms, which prefer a neutral pH around 7. The salts also create osmotic stress on worm skin. Earthworms breathe through their skin, and when that skin is exposed to concentrated chemical salts, it functions like pouring salt on a slug. They dehydrate and die or leave the area entirely. Pesticides are the third hit. Even pesticides that aren't specifically targeting worms often kill them as collateral damage. Fungicides destroy the microbial communities that worms depend on for food processing. Herbicides remove the surface vegetation that worms need for food and shelter. The soil becomes a chemical wasteland where nothing in the food web can survive. And then there's bare soil. Unmulched, exposed dirt bakes in the sun, getting hotter and drier with every passing hour. Worms are cold-blooded animals whose bodies are 80% water. They need cool, moist conditions to survive. Surface soil temperatures in an unmulched garden can exceed 130 degrees on a summer afternoon. No worm will voluntarily enter that environment. They'll retreat to deeper soil layers where temperatures are tolerable, leave the area entirely, or simply die. And even if they survive the heat, bare soil dries out so fast between waterings that the top few inches become uninhabitable. Worms breathe through moisture on their skin. Dry soil is the equivalent of a vacuum for them. Here's a simple test you can do right now to find out how your garden scores. Go outside. Dig up 1 cubic foot of soil from your garden bed, roughly 12 inches by 12 inches by 12 inches. Dump it on a tarp or piece of cardboard and count the worms. If you find 10 or more earthworms in that cubic foot, your soil biology is in decent shape. 5 to 10 means it's struggling but recoverable. Fewer than 5 or none at all means the conditions in your soil are actively hostile to worm life, and your plants are feeling the consequences whether you've noticed or not. The irony is that every one of these worm-killing practices, tilling, chemical fertilizing, spraying pesticides, leaving soil bare, is done with the intention of helping plants grow. Gardeners till because they think loose soil is good for roots. They fertilize because they think plants need more nutrients. They spray because they want to protect their crops. And they leave soil bare because they think it looks tidy. Every single intention is good, and every single result is bad for the worms and ultimately for the garden. The worm magnet method isn't about buying worms and dumping them in your garden. That almost never works long term, and it's the mistake that kills most people's first attempt at worm gardening. If the soil conditions are hostile, purchased worms will either die or migrate away within weeks. They'll tunnel down and out seeking better ground, or they'll surface at night, cross the lawn, and end up in a neighbor's mulch bed where conditions are more hospitable. You've spent money on worms that are now improving someone else's soil. The fundamental problem was never a lack of worms. Worms are already in the ground. They're in the compost pile, under the neighbor's leaf litter, along the edge of the driveway where organic debris collects. They're just not in your garden bed, because your garden bed is an environment they can't survive in. Instead, the worm magnet method is about changing the soil environment so dramatically that worms from the surrounding area migrate in on their own. You're not importing workers. You're building a habitat so attractive that the workers show up voluntarily and never leave. The method has 4 steps, and none of them require anything you'd need to buy at a garden center. Step 1 is the cardboard layer. Take sheets of plain corrugated cardboard, the brown kind from shipping boxes, and remove any tape, staples, or glossy printed labels. Glossy coatings and colored inks can contain chemicals you don't want in your garden soil. Flatten the boxes out and lay the cardboard flat directly on the surface of your worst soil. Overlap the edges by at least 4 to 6 inches so weeds can't push through the seams. If you're covering a large area, keep overlapping. Every square inch of soil should be covered. Then wet the whole thing down thoroughly with a hose until the cardboard is completely saturated and heavy. This does several things at once. The cardboard immediately blocks all light from reaching the soil surface, which kills existing weeds without any chemicals or pulling. It traps moisture against the ground, creating the damp, dark environment that worms need to survive near the surface. And as the cardboard begins to decompose over the following weeks, it becomes food. This is the detail that makes cardboard specifically so effective. Earthworms are biologically drawn to decomposing cellulose. The carbon-rich fibers of corrugated cardboard are like a dinner bell for worms in the surrounding soil. They will move toward it from surprising distances, sometimes migrating from 30 feet away or more, drawn by the chemical signals that decomposing plant fiber releases into the ground. Step 2 is the mulch blanket. On top of the cardboard, spread a thick layer of organic mulch. Straw, shredded leaves, wood chips, or a combination of all 3. Aim for at least 4 to 6 inches deep. Don't be shy with it. The mulch layer serves the same function as a forest floor, which is the environment where earthworms evolved and where they naturally thrive in the highest densities. If you've ever kicked apart a pile of rotting leaves in the woods and found the soil underneath, crawling with worms, that's the effect you're replicating. The mulch insulates the ground from temperature extremes, keeping the soil cool during scorching summer days and warmer during early spring freezes. It holds moisture like a sponge, dramatically reducing how often you need to water. And as it breaks down over weeks and months, it adds a continuous supply of organic matter that feeds the worm population from above. The worms eat from the bottom of the mulch layer, pulling decomposing material down into their tunnels, and fresh mulch settles in from the top to replace what they've consumed. It's a self-replenishing system. The combination of cardboard underneath and mulch on top creates what permaculture growers sometimes call a worm sandwich. The worms congregate between the two layers, feasting on the decomposing cardboard from below and the rotting mulch from above, all while depositing their nutrient-rich castings directly into the soil surface. If you lift the mulch after a few weeks and peel back the softening cardboard, you'll see the evidence. Dark, crumbly trails of castings marking the paths where worms have been feeding. Step 3 is feeding. Once the cardboard and mulch are in place, you can accelerate the process significantly by adding nitrogen-rich organic matter. Worms need both carbon and nitrogen to thrive, and the cardboard and mulch provide the carbon side. The nitrogen comes from living or recently living materials. Compost spread over the mulch layer works well. So does aged manure, coffee grounds from your morning pot, or thin layers of kitchen scraps tucked under the mulch where they won't attract rodents or raccoons. Crushed eggshells are a particularly good addition for two reasons. They provide calcium, which earthworms need for reproduction. The shells of their egg cocoons are made from calcium carbonate, and the gritty texture helps worms grind food in their gizzard the same way small stones help a chicken digest grain. No grit, no digestion. The eggshells solve both problems at once. One technique that experienced worm gardeners use is to create feeding stations. Choose 3 or 4 spots across your garden bed. Lift a corner of the mulch every week or two and deposit a handful of kitchen scraps, banana peels, melon rind, coffee grounds, or vegetable trimmings, directly on the cardboard surface. Replace the mulch on top. The worms will find these deposits within days and concentrate their activity around them, building up dense pockets of castings exactly where you want them. Over time, you can rotate the feeding stations to different spots, ensuring that the entire bed gets enriched evenly. A detail worth mentioning here is what not to feed. Avoid citrus peels and onions in large quantities. The acidity and strong compounds can repel worms in concentrated amounts. Avoid meat, dairy, and oily food scraps, which attract rats and create odor problems. And avoid any plant material that's been treated with herbicides because those chemicals persist through decomposition and will harm the worms you're trying to attract. Step 4 is the hardest for most gardeners because it means changing a habit that feels productive even when it's destructive. Stop disturbing the soil. No tilling, no rototilling, no double digging, no turning the beds over in spring because that's what your parents always did. The worms are building an intricate network of tunnels that functions as permanent infrastructure for your garden. Every time you till, you demolish that infrastructure and force the worms to start over. It's the equivalent of building a highway system and then bulldozing it every March. In a no-till system, those tunnels remain intact year after year, getting deeper and more complex as the worm population grows. Water infiltrates faster because it follows the vertical channels anesic worms have drilled. Roots penetrate deeper because they grow along the nutrient-rich burrow walls. Air reaches the root zone because the horizontal tunnels created by endogeeic worms function as ventilation shafts. The entire underground architecture improves with age, which means your soil gets better every single season instead of resetting to zero. If you need to plant seeds or transplants, just push the mulch aside, cut a small hole in any remaining cardboard, and plant directly into the soil beneath. The worms will have already loosened and enriched that ground more effectively than any tilling could. After planting, push the mulch back around the base of the plant. The worms will keep working undisturbed, just inches from your growing roots. Some no-till gardeners use a broad fork to gently loosen deep compaction without flipping the soil layers. That's acceptable because it opens channels without destroying the worm tunnels or mixing the soil profile. But for most backyard gardens, even that isn't necessary once the worms have had a full season to establish themselves. There's one more practice that supercharges this whole system, and it's one that most home gardeners overlook entirely. Keep living roots in the ground as much of the year as possible. When your summer crops finish, don't leave the bed bare over winter. Plant a cover crop, crimson clover, winter rye, hairy vetch, or a simple mix of oats and peas. The roots of these plants exude sugars and amino acids into the soil that feed microorganisms, and by extension, feed the worms that depend on those microorganisms. Living roots keep the soil biologically active through the cold months when everything else shuts down. When spring comes, you chop the cover crop at the base, lay it flat as a new mulch layer, and plant directly through it. The worms pull the dead plant material underground and convert it to castings. The cycle continues. The timeline for visible results depends on your starting conditions, your climate, and how much organic matter you're adding. But here's a general guide for what to expect. Within the first 2 to 4 weeks, if you pull back the cardboard on a damp morning, you'll start seeing worms congregating underneath. They're arriving from the surrounding soil drawn by moisture, food, and shelter. You might see just a few at first, but the numbers build quickly. By month 2 or 3, the soil under the cardboard will be noticeably darker than it was when you started. That darkening is organic matter being incorporated into the soil profile by worm activity. The soil will also be softer. Where it was once hard-packed and resistant to a shovel, you'll be able to push a finger into it with almost no effort. You'll also notice the smell changing. Dead soil smells like nothing, or sometimes faintly metallic. Living soil has a rich, clean, earthy scent that's caused by a compound called geosmin, produced by beneficial soil bacteria. If you can smell it, the biology is working. By month 4 through 6, the cardboard itself will be mostly consumed, chewed up by worms and decomposed by fungi until only traces remain. What's left is a layer of partially decomposed mulch sitting on top of soil that's been visibly transformed. Darker color, crumblier texture, better moisture retention, and earthworm castings visible on the surface as small granular mounds that look like tiny clusters of dark soil pellets. By the end of the first year, you'll have an established worm population that regenerates itself. The worms breed, lay cocoons in the soil, and expand their territory naturally. A single earthworm can produce between 3 and 80 cocoons per year, depending on the species, and each cocoon can contain multiple baby worms. As long as you keep feeding the system with mulch and organic matter, and keep your tools out of the ground, the population will continue growing, and the soil will keep improving year after year for free without you buying a single bag of fertilizer. There's one more layer to this that connects everything back to the global scale. Healthy, worm-rich soil doesn't just grow better food, it stores carbon. Every tunnel a worm digs, every casting it deposits, every piece of organic matter it pulls underground and stabilizes is carbon being removed from the atmosphere and locked into the ground. Agricultural soils worldwide have lost roughly half their carbon stocks since humans started farming them. Much of that loss comes from practices that destroyed the soil biology that keeps carbon stable underground. Practices like heavy tilling, chemical dependence, and bare fallow fields. The same practices that drive worms away. Rebuilding worm populations rebuilds the soil's ability to hold carbon, hold water, cycle nutrients, and support plant life without external inputs. It's not a new technology, it's the oldest technology there is. Worms have been doing this for 600 million years. We just spent the last century getting in their way. Darwin understood this before anyone else. He watched these eyeless, boneless creatures reshape the English countryside one grain of soil at a time. And he recognized something that the rest of the world took over a century to accept, that the fate of the world's food supply is tangled up with the fate of an animal that most people step over without noticing. The real question isn't whether worms can fix your soil. They can. The question is whether we're willing to stop doing the things that drive them away. If this story changed the way you look at the humble creatures beneath your feet, please subscribe to our channel and like this video. We are uncovering the hidden history and biological secrets that have been buried for too long. Let's cultivate a better future together. The next treasure of the earth will be revealed soon.